Not. Correct way to do it. Now you can see what is the problem here. The problem is the force is not in the same direction as the direction. That is the problem. Now, if you're high school kids, they do this. It's force and distance. Yeah, and everything's in the same direction. So they don't think about vectors. Really. But if you do something like this, everything's changed. You have a force by this way, and the distance that you're pushing that thing with this way. So it really becomes, what component of that force? What you basically have to do is this. You have to resolve this force as you have to resolve it as that. So the component of the force in that direction is not doing any work in that direction. Well, now you can give it to your, say, FA, FB. Now you can give it to your high school kid. You say, everything's in the same direction. It's that time. Take off the direction now because it's in the direction. This one here, well, not in the right direction. So, what is going on is the force is not acting in the same direction as the direction in which the body is moving. So in some sense, the dot product must tell us something about this thing. And that is correct. Well, the dot product, if you ask me what is the dot product, I can give you many, many interpretations. But really, it measures the angle between the two vectors. Now, I'm not going to prove it to you. I can try to convince you. I'll do it in 2 dimensions. Right? I'll do it in 2 dimensions. You can trust me, this is the proof, but you don't have to take my word for it. So give me 2 forces. Who will give me 2 forces? Give me a force U and 2 vectors. And another vector.
A, B, C, D.
So A is completely in the x direction. Okay. So this is the vector V. Clear. Which is A along and 0 up. And let us take the vector. Oh, sorry, this is the vector U. I'll take my glasses. Eraser. And this is my vector B. Now, what is the dot product?
AC.
Dot product is AC. Now, do we all see that A is the length of U? So U dot V is the length of U. Now what is C? Well, we now do some trigonometry. What is C? So what is this? The length of
V.
the length of V. What is C? You all see that C over the length of V is the cosine of the angle between the two vectors. Who does not see that? Huh? You see it, Mr. Collas,
Yep.
if you know your basic trigonometry. That C over the length of V is the cosine of the angle between the two vectors. So that C is what?
Inverse C is cosine theta times magnitude of V.
Absolutely correct. And there you have it. That the dot product is the length of u times the length of v times the cosine of the angle between the two vectors. That is a nice geometrical interpretation of the dot product. I write it like this. If you want to know the angle between the two vectors, take the dot product, divide by the length, you'll have the cosine of the angle. The cosine of the angle between two vectors is the dot product divided by the length. That is the really proper interpretation of the dot product. It measures the angle between the two vectors. And now, the great thing about this is it doesn't matter what dimensions you're in. What is the angle between two vectors in 30 dimensions? Well, take the dot product, divide by the length, and you'll have the cosine of the angle between the two vectors. And then you just take the inverse cosine, you'll have the angle. So here is an example. So, I need to do this. What is the dot product? Which is 3. Now I need the length of u, and I need the length of v. What is the length of u? This is the square root of square root of 14. And what is the length of v? Square root of 1 squared. Squared. 1 squared, which is square root of 1. Square root of 4. So the cosine of the angle between these two vectors. No, sorry. Oh, square root of 6. The cosine of the angle between those two vectors is the dot product divided by the lengths. And then I'll do my inverse cosine and I'll have the angle. Clear? Who can tell me what angle that is in degrees? Make sure you calculate it in degrees. So, you can remember this? Or you can remember this. What was the same way it was? What angle is that, Mr. Colas?
52 degrees.
52 degrees. So here are two vectors lying in space. They are lying in space. Tell me the angle between them is 52 degrees.
70. Yeah.
Oh, you guys need some coffee, huh? Oh, whatever. Blah, 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 blah.
70.
Whatever. Only do it. Okay, so that's partly why dot products are. Why we do dot products.